Now let's discuss the last topic of this chapter, which is impedance shift. So we were discussing in the last topic as how the impedance connected on the secondary side is seen on the primary side. So on the primary side, the impedance connected of this on the secondary side is seen as the product of that impedance times the square of the turns ratio. So this property of transformer, that it relates the primary impedance and the secondary impedance using the square of the turn ratio, can be utilized by shifting everything that is connected on the secondary side towards the primary side, which we call secondary side reflection on the primary side, or secondary side shift on the primary side, or vice versa. We can shift the primary side impedance, load, and everything, not load, sorry, impedance, voltage, current, everything on the secondary side, which we call primary reflection on the secondary, or primary shift on the secondary. Now when this is necessary, so any circuit can be solved using the impedance shift or impedance reflection, but sometimes it is necessary to do that. And when it is necessary to do that, here it is given in red color. If you do not know the primary or secondary current, or the primary and secondary voltage, or actually not or, and, so you don't know I1, I2 and E1, E2, you don't know any of these quantities, then it is necessary for you to shift either the primary to secondary or secondary to primary, based on what exactly you are calculating. So let's look at how do you shift. If you're shifting the secondary side on the primary side, so this is you have the secondary side here. Z2 is the line impedance, ZL is the load, Z1 is the line impedance on the primary side, Z2 is the line impedance on the secondary side. So you want to shift. Basically what we are trying to do, we are trying to eliminate this transformer E1 and E2, and basically we are trying to create one circuit with one single loop connected with ES when we are shifting secondary side on the primary side. How do we do that? We use different transformer relationships, that is E1 over E2 is equal to N1 over N2, or turn ratio. I1 over I2 is equal to N2 over N1, that is 1 over turns ratio, and primary impedance Z1 equals to A squared times Z2. So any impedance that is connected on the primary side is equal to A squared times the impedance that is connected on the secondary side. So if we want to reflect any impedance from the secondary side to the primary, what we have to do is to multiply that impedance by A square, and then we can reflect that impedance on the primary side. Likewise, any voltage on the secondary side, when it is reflected on the primary side, since E1 over E2 is A, we multiply that voltage that we are reflecting from the secondary side to the primary side by A, and then we can use it on the primary side or reflect it on the primary side. So, and same goes for the current. Any current that we want to reflect on the primary side, secondary current on the primary side, we divide it by A, and then we can reflect it on the primary side. So look at this. From this circuit, when I reflect Z2 on the primary side, I call it Z2 prime, and when I reflect ZL on the primary side, I call it ZL prime. Now what are Z2 prime and ZL prime? Z2 prime is A square Z2, ZL prime is A square ZL. And likewise, the voltage across the load, I'm calling it EL, is also reflected on the secondary side, on the primary side, and that will be A times EL, because the voltage on the primary side is equal to, or the ratio between the voltage on primary side and secondary side is equal to the turn ratio. So voltage on the primary side is equal to A times the voltage on the secondary side. So any voltage that you reflect from secondary to primary is multiplied by the turn ratio A. Likewise, any current that you reflect from secondary to primary is divided by A. So since it's a single loop, this current is I1, but this I1 is what? I2 over A, as we have discussed earlier. So in this way, you basically eliminated the transformer. You reflected Z2 and ZL, I2 and EL should be here, every quantity on the primary side. And now you have a single loop. From the single loop, you can apply Ohm's law easily. You can calculate I1, ES over Z1 plus Z2 dash plus ZL dash. When you know I1, you can calculate I2. Of course, I2 over A is I1, so you can calculate I2 from there. You can calculate the load voltage over here, and then you can calculate what will be the load voltage actually on the secondary side. So you can calculate EL dash, and then divide that by A to calculate the actual voltage across the load on the secondary side. And if you're calculating the power across the load, then either you use the primary side or secondary side. The power will be same, as we have discussed. The power across the primary and secondary does not change. So make sure you use this method, especially or specifically when you do not know I1, I2, E1 and E2, any of these quantities. You must use this method. You can also go from primary shifted on the secondary. So all the values, everything on primary shifted on the secondary side. Look at that. So my primary source voltage is shifted on the secondary side. I'm calling it ES double prime. And likewise, my primary line impedance Z1 is shifted on the secondary. I'm calling it Z1 double prime. And my primary current is shifted on the secondary. I'm calling it I1 double prime. And I'm gonna make use of the same relationship to calculate the values of ES double prime, Z1 double prime and I1 double prime. That is, Z1 double prime is now Z1 over A square, I1 double prime is AI1, and ES double prime is ES over A. So basically I'm using the basic relationship of transformer, that is E1 over E2, primary over secondary voltage is equal to A, primary over secondary current is equal to 1 over A, and primary over secondary impedance is equal to A square. So I'm using these, I'm taking advantage of these three relationships to either go from primary side to the secondary side or secondary side to the primary side. So this is called impedance reflection from one side to the other side, and we will do example number 3 based on this impedance reflection.